Our next speaker is Gary Cowger. Gary is the Chairman and Chief Executive Officer of GLC Ventures and retired as Group Vice President of Global Manufacturing and Labor Relations for GM, where he spent most of his career. I know he has lots of slides, so I'm going to cut the introduction short. Gary's a member of the National Academy of Engineering, and he's going to speak to us today about energy challenges for the light-duty vehicle fleet. Gary?
Thank you, Mark, and it is a pleasure to be here today. I always like coming over to Ann Arbor. It wasn't particularly good this morning, as you said, because I guess there was a big problem on 23. I think the reason that I got invited to speak here today is because I recently, through the Academy, served on a committee that we spent 2.5 years working on advanced vehicles and fuels. That was really quite an interesting assignment. It came out of the National Science Foundation. But the mandate, sorry about that. No, actually I didn't go the wrong way. There we go. The mandate, and I don't know, David, if you're still here, if you were at the DOE at that time, but the mandate came from the DOE fiscal year 2010 on the Energy and Water Development Appropriation Bill. And basically what it was saying was assess the potential for vehicle and fuel technology options to achieve substantial reductions in petroleum and greenhouse gas emissions by 2050 relative to 2005. And why all that interest, obviously, is because internal combustion engines have been operating on petroleum fuels which have powered almost all of the vehicles in the United States for the past century. And they have accounted for about half of the petroleum use in the U.S. over that period of time. About half of that fuel is imported, and that light-duty vehicle fleet also accounts for about 17% of the total U.S. greenhouse emission. So it always, as a sector, has a spotlight, and rightfully so, on it. So the committee was actually quite a diverse and distinguished committee. I want to say right up front, I'm not a researcher nor a scientist. I think I was asked to join this committee because I have made a few things over my career and tried to bring kind of that manufacturing focus to it. But as you look there, there's a lot of distinguished people on that committee. What we ended up doing was dividing into 4 teams. One was on fuels, because we had a lot of oil patch guys there. Vehicles, which I ended up serving on. Modeling and policy. Now, I'm not going to talk much about fuels, modeling, or policy this morning. I'm going to try to stick to vehicles. But I will say that fuels play a big part if you're going to make some of these grand challenge kinds of goals. And I see John out in the front. John was also a member of our team, and I think, John, you were on the policy committee, correct? So the statement of task, the mandate then relates itself to a statement of task, and it was like this. Relative to 2005, how can the on-road light-duty vehicle fleet reduce petroleum use by 50% by 2030, 80% by 2050, and how could greenhouse emissions be reduced 80% by 2050? Assess the cost and performance of the vehicle and fuel technologies that would allow us to meet these goals, and what kind of barriers would there be to their adoption. Suggest policies to achieve the goals, and that ends up being a big focus of the report. And then comment on the federal R&D programs that could actually support meeting these kinds of grand challenges. Well, I've got to say, 2050 gave some of us a little pause because there's not much in the literature out to 2050, so it reminded me of what Charles Babbage said way back in the 1800s, errors using inadequate data are much less than those using no data. So we used what data we could find out there, and it ended up being, by the way, about a 2.5-year study. We came up with 4 pathways that could contribute to both goals. A continuation of highly efficient internal combustion engines, vehicles operating on biofuels, and in this case, we're talking more about the so-called drop-in fuels, not corn ethanol, but the more gasoline biofuel replacements where you don't have to change the infrastructure. Vehicles operating on electricity, and in there we looked at a hybrid electric vehicle like a Prius, a plug-in hybrid like a Volt, and of course a battery electric like a Leaf. And then vehicles operating on hydrogen, and in most cases that we focused on fuel cells. Natural gas, and we've talked a lot about that already this morning, vehicles reduce petroleum consumption, but have a minor impact, as I'll show you later, on the greenhouse gas emissions, because for this report and for our modeling, the greenhouse benefits of biofuels, electricity, and hydrogen depended on them being produced without large greenhouse gas emissions, which obviously expands the need for controlling these emissions far beyond just the transportation sector. And I would say John carried that banner for us quite well. So, the potential scenarios that we came up with, and let me just say these are not predictions. They're scenarios of what could happen if there were a major national commitment to make these kind of goals a reality. We identified promising combinations of fuel and vehicle pathways. The combinations were qualified and analyzed to assess their capacity to meet these aggressive goals and determine required policies, and I'll talk a lot about policies. And quite frankly, given that there's this will to do this, several scenarios are promising, but all require strong and effective policy support at the national level. All successful pathways, no matter what, include the vehicle internal combustion engine continuing to make the great strides they have on efficiency. But as you'll see, market acceptance will be the key. So some of the general assumptions of the report. Cost assumptions, we assumed all costs to be high volume, so at full production. The ICE costs were not specifically adjusted because John Haywood was on the committee. He's done a lot of good work at MIT on this, and we basically used his figures. We did deep dive, though, into the differential costs of internal combustion to hybrid, hybrid to plug-in hybrid, and battery, electric, and fuel cell. And we carefully assessed those costs, had experts on each of those systems on the committee. And the other assumption we made is that powertrains would be downsized to maintain consistent performance. I'll show you a chart in a little while where we've improved performance and efficiency. We kind of assume going forward that performance is going to stay kind of in the range of where it is, and all of this improvement will go to efficiency. Now, the results may be conservative, and you say, holy cow, how can you have conservative results with those kind of goals? It's simple. We didn't use carbon fiber at all, and I know there's a lot of work going on, particularly in Asia, on making carbon fiber much cheaper to use and could have a much broader spectrum of use across vehicle types. Now, because of the expense, you really basically only see it on premium cars. Batteries beyond lithium ion were not considered. We didn't talk about lithium air. I know today we're going to talk about a battery lab here. GM has a big battery lab, but we didn't consider anything other than cost improvements on lithium ion. There is a cost curve that we followed. Fuel cell efficiency gains were much less than theoretically possible. We decided to be on the conservative side there. And off-cycle improvements like AC efficiency, solar cells on the roofs, cabin heat management were not considered in this. And I think David mentioned this morning that supercomputers are starting to make a big difference in the energy equation. Same thing in the auto industry. I think a lot of this lightweighting and a lot of the things that can be possible going forward will be because of our supercomputing capability and being able to optimize systems as a whole. So our policy suggestions came out this way. Strong and effective policies are required to achieve any scenario's success. None of them can just fly on their own. Policies must drive the use of light-duty vehicle advances in fuel economy. So the same kind of advances the CAFE are now imposing on the auto industry are assumed to continue. Policy must drive changes to non-petroleum fuel infrastructure, and here's where you get into big greenhouse gas fluctuations. So to meet that goal of 80% is going to take a huge look at the fuel industry and infrastructure. And uncertainties make it impossible to know which technologies are going to win. So we have suggested that we try to, in R&D, stay technology neutral and let the marketplace determine, along with the private sector, which of these technologies are going to be best accepted with the consumer. So the policies should be broad, robust, and adaptive. So at the end of our modeling, you can see across the axes there that the top dotted line is a 50% reduction, and this one is petroleum consumption. And quite frankly, there was 4 or 5 of these that could meet the 2050 goal. Now again, I have to keep reiterating, with all this policy intervention. However, when you looked at greenhouse gas, not so much. Here's the one where you see the natural gas vehicles, where they do a great job on reducing petroleum, not so much on greenhouse gas. Only about one of the scenarios really got us to the 2050 goal, and that was with some very heavy policy intervention. You can get much more details on this from the report, which you can download online. Our key findings, though, were that the goals will be very difficult, but not impossible if, and it's a big if, supported by strong national policies. No pathway is adequate by itself to meet the goals, and at least 2 and maybe more will be needed depending on technological and commercial success between now and then. Improved efficiency is essential no matter what pathway, as I've said. And, the internal combustion engines made huge improvements over the last 30 years, pumping losses and those sorts of things. And I think as supercomputing continues to help, we'll see continued improvement in powertrain. But I got to say, even if the goals are not met completely, partial success is still a big win for the U.S. consumer and energy independence. There's a number of findings in the report, but there was 2 I just wanted to point out. One was this one, that the progress and the policies need to be pushed on a nationwide basis. It's very difficult for the manufacturers when each state tries to do their own thing, because that's not how cars are sold or trucks are sold across the U.S. So it really does need a nationwide focus. And what I just said, even if we fall short, there are environmental, economic, and national security benefits that result from the petroleum use and greenhouse gas emission reductions. So, what are the challenges for the auto industry in all this? And I'm not just talking about the challenges on the report for the DOE Grand Challenge, but even for CAFE and in Europe, the CO2 standards that have been enacted. Cost is an issue. It's a market issue. All vehicles considered in our study will be several $1,000s more expensive than the 2013 conventional vehicle. And as you're seeing play out in the market right now, near-term costs for battery and fuel cell vehicles will be considerably higher, even with the manufacturers absorbing some of that cost. Now, of course, driving costs will be lower, but, and particularly if you use natural gas and electric fuels. But again, the consumer is going to make that trade-off on where is the price of gasoline. Somebody asked this morning to consider putting a floor on the price of natural gas. I would say, you know, the other question there is, anybody considered putting a floor on the price of gasoline? Most politicians probably wouldn't do that. And I think vehicle cost is likely going to be a significant consumer issue for the next decade. When you looked at the modeling on our project out through 2050, and these are all the various technologies and propulsion systems, you can basically see, and this was the mid-range. This wasn't the optimistic. This was the mid-range. There's about a $4,000 to $6,000 increase, depending on the technology, for the consumer during that period of time. The other challenge that the manufacturers have, and I would say most people don't think about, other than the people in this room, obviously, but the study assumed that total vehicle miles traveled would almost double by 2050, meaning that we were at 2.7 trillion miles in 2012. That was going to, or 2005, that's going to go to 5 trillion miles in 2050. So these 50 and 80% reductions are on double the use of fuel and miles driven. So it just gives you a little feel for some of the challenges. I think the market acceptance is also an issue. One thing that's true in the market is mandating a particular technology doesn't make consumers want to buy it. There has to be a compelling reason, either incentives, cost, your pocketbook, you do the math. There's got to be a compelling reason, other than early adopters, to get broad-scale use of these technologies. And historical trends regarding market acceptance, we talked a little bit about that this morning as this energy sector has moved from one source to another, are a long period of time. And I'll talk about that here in a minute. But I think there are encouraging signs. Some of the technology that's not so broad, like a propulsion change, but more of an enhancement on internal combustion, will come faster than we think. Now, again, John Haywood's done a lot of good work in this area. This was some work he did for the SAE on how long it takes to get a feature or a piece of equipment into the marketplace. And you can see this chart kind of goes from the 40s over a 100-year period of time. Let's take a specific one. This one's engine management systems, and you can see the technologies that it takes to build up a total market acceptance of engine management, which includes fuel injection, and you can see carburetors kind of going away. Well, in the 1950s and 60s, carburetors were the big thing. Today, you don't see it at all, but you're also talking a 40, 50-year period of time here that it took to get this huge fleet changed to a new technology. In fact, John looked at it from several different perspectives. The first, gasoline direct injection and turbocharging. He thinks that's about the quickest, looking at previous introductions at about 20 years, all the way up to fuel cells, hybrids, and onboard hydrogen storage that takes like 50 years to get a full implementation. So the point here is this stuff just doesn't happen overnight. And the consumers are very slow to react to this unless they see a big reason that it helps them financially. They're truly rational consumers. Now here's the good news part of this. Between model year 2007 and 12, these technologies seem to be, and particularly some of them, moving very quickly and finding themselves embedded into the fleet. Variable valve timing, that kind of goes along with this engine management. it goes along with the increase of computerization that's being able to be happening now with this engine management program, multi-valve engines. Also, 6-speed transmissions. I think you'll see a migration to 7-speed. I just saw an article about 9-speed. I don't know where all the speed ends, but at some point, because of the optimization there, I think all of these things will continue to find their way into the fleet faster than a major propulsion change. And, I give the OEMs credit, I'm probably biased, obviously, but there are a lot of choice in the marketplace today for consumers that want to find better gas mileage and therefore better greenhouse emissions across the spectrum. And we have more cars today that get over 40 miles per gallon from all manufacturers than we've seen before. But let's look at a propulsion change. So David said this morning how many people have plugged their cars in last night before they got up to come here this morning. I didn't see what it was, but I didn't need to see it. It's about 3% of you, because that's about the take rate that it's been over the last 13, 14 years. So this is typical of what it takes to really start to bring on in a mass market way. And this includes, by the way, the Prius, which is the first hybrid, and I'll show you here in a minute, that kind of warps the numbers a little bit. But one more time, I'll say that it's not because the manufacturers aren't trying. Here's the number of nameplates from hybrids, which could include light hybrids to heavy hybrids to plug-in hybrids, that are in the marketplace now for consumers. So the manufacturers are spending a lot of money on this. The manufacturers are getting a lot of these products out into the market. But again, it's this reluctance of changing dramatically, because what does it mean? It's more expensive than what I'm going to see in fuel savings, particularly when fuel prices can come back down. The other thing about this is the Prius, which is the light blue there, is about 65% of that penetration. And so it kind of warps the penetration numbers. I'll show you some numbers here in a minute from Edmunds that gives you the exact numbers. But once again, I'll say these manufacturers are out there with it, but clearly Toyota has kind of the leading edge spot here because of them bringing that technology into the market earlier than anybody else. But here's an interesting part. When you start to look at plug-ins, and I explain hybrid electric as a battery helps an engine. It doesn't drive the car, but the battery helps the engine. A plug-in electric, the engine helps the battery, because the engine now is a little generator. You only run on electrical power. You don't run on a dual system. And that's the interesting change here. And the other thing about plug-in hybrids is it takes away this whole idea of range anxiety. So you can get so many miles on pure electric, and most consumers, if I remember all the numbers, 85% of commutes in the U.S. are less than 40 miles round trip. If you can plug in at work, that really makes it easy. But you would never have to use your generator to generate electricity. But that's what the gasoline would be used for, and obviously that's why you see the mile per gallon equivalents on plug-in hybrids way up there, 2x what the hybrid vehicles are. So here's an interesting chart that a Prius plug-in hybrid is off to a much faster start than the Prius, which is in the orange there. Now, a lot of that's because Toyota is seen as kind of being a leader in this technology. But look at the Volt. The Volt now is on a faster acceptance curve than the Prius was during its first months of introduction. The other interesting thing about this chart is the leaf here, which represents a battery electric or a pure electric vehicle. There's still reluctance there by consumers because of expense, because of range, because of a lot of reasons. And that take-up rate is really not going as well as the plug-in hybrids. I got some figures out of Edmunds, and in 2012 there were, and these are all hybrids, typical hybrids, HEVs, 430,859 sold in the U.S. That was against a 14.5 million unit fleet for a 3% penetration. Now, if you look at plug-in hybrids, there were 36,007 sold. Volt sold the majority of that. That accounted for 0.2% penetration. And then if you look at just pure electric vehicles, there were 12,000 sold, and that was 0.08% penetration. So these things, when people talk about having a, consumer acceptance period of time that just takes to get used to the technology, it's real when you look at the numbers, and it's real when the manufacturers look at how are they going to get this adopted quicker. Well, one of the ways is to look at incentives, both not only from the manufacturer, which they're already doing, but from the states. And here's a case where if you look at California compared with, let's say, the Northeast states that just decided to do a ZEV standard like California did, California is using a lot of clever ways to try to entice buyers to buy that technology. One of them is, using the commuter lane. And anybody that's ever lived out in LA, in and around there, being able to use the commuter lane is a big deal. And it shows up in the sales of not only HEVs, but PHEVs, as opposed to the other states that have the mandate, but don't really have the incentives. Now, there are weather issues, there are other issues, but I think it shows on a broader basis that there can be some very smart, efficient incentives that can make sense to consumers and maybe help pick up the introduction of some of these technologies. But cost is still going to continue to be an issue here until we see breakthroughs in battery technology and that sort of thing. I threw this in at the last minute because all of a sudden fuel cells are back in the news again, and there's a great article on it this weekend. I happen to be a big fuel cell fan. Toyota is actually the one that made the news here, saying that they will be in the market with a 4-passenger sedan in the U.S. in 2015. They're going to show it at the Tokyo Motor Show this year. Honda, of course, is leasing the Clarity already in L.A. They've said that they're going to bring a new line of fuel cells by 2015. General Motors, well, I was still there. I don't know if Larry's still here. Larry Nitt's still here. Put 150 fleet, oh, hi Larry. Put 150 fleet of Equinoxes out, did a great job with that, have spent lots and lots of money. Larry headed a lot of that effort on fuel cell development. Hyundai announced that John Krafcik, if I read it right, said they're going to commercialize fuel cells here next year in the U.S. Ford, Mercedes, Nissan, and Renault have fuel cell development alliance. Honda and GM announced earlier in the year that they have an alliance for advanced vehicles and fuels. So my point is here, a lot of people are putting a lot of money still into fuel cells because when you look at greenhouse gas emissions, fuel cells make a lot of sense. And, maybe we got out there pretty early saying fuel cells would be ready by 2015. I think maybe 2020, that may be the time where fuel cell technology really starts to come into its own. The cost of fuel cells will come down dramatically with the volume. The reason these things are so expensive right now is still the materials. And you go back and look at the catalytic converter, look how much precious metal was in the original catalytic converters, and look how much is there today, and they do a better job. Things are going to happen on fuel cell development. It's going to continue to get better and better, and we're going to continue to drive the costs down. The problem is we still need an infrastructure for fuel cell technology, and that's hydrogen. Japan, Germany, and South Korea have government programs to create initial networks of hydrogen fuel stations. And the other thing fuel cells do is they get rid of the two things that pure electric vehicles, the consumers kind of complain about. One's the recharging time, and the other is the range issue. That, in fact, I read an article this morning where it said that the rental companies are really struggling to try to rent these battery vehicles now because of customers' range anxiety. Fuel cell solves both of those issues. You can recharge it in about 3 to 5 minutes, and you're going to get the same range as you do with a product that's driven by petroleum. So how is the auto industry doing? I think there's real progress being made. When you look from 1970 through basically 2005, the total miles driven more than doubled. In fact, it's up about 2.5. And the increase in oil and CO2 was not nearly as much as the vehicles driven because of the efficiencies and controls that were put on. But even in that, there was a lot put to performance that I think now will be focused on improvements. But the good news on this chart, fatalities, even with all those miles, and air pollution down dramatically over that period of time. And there's kind of been a very favorable multi-year trend that began when this chart left off in 2005. And you can see we're really starting to bend the curves now on both adjusted CO2 emissions and fuel economy, which actually go hand in hand. And if you look at the new CAFE standards going out through 2025, you look at what the European Union has put, they of course look at CO2, and China's standards, you're going to see continued improvement, dramatic improvement in the industry. Now, it will get harder and harder and more expensive as these improvements continue to tighten up. I give the industry a lot of credit here, and also the DOE on the new CAFE standards on getting everybody's input into these, and you can see the performance has been terrific so far, and in fact a little overachieving in 2012 and 13, but the knee of this curve gets harder and harder as you go up. It starts to get more expensive, it starts to take more consumer acceptance to get the fleet there. So I think, and when you look at the standards that go beyond that, out from 2017 to 2025 and beyond, they're just going to continue to be more and more challenging. So I thought one of the very intelligent things that all parties did in this was put a 2017 review of the standards with the industry so that market acceptance, cost, all these things could be looked at to make sure that the end result is we want consumers buying more and more of this technology so that we're improving fuel economy and emissions. And that's coming up, and I think, I just think it was a very intelligent thing to put in. So in summary, I think attaining these difficult goals is really not as much a technology issue for propulsion systems, because we've seen it. We've seen battery electric, plug-in hybrid. We know how fuel cells work. It's more the optimization of that now. So it's a cost. That's getting the volume up, getting the market acceptance up. It's infrastructure. Do we have the ability to make it convenient for consumers to use this stuff and these new fuels? And of course, market acceptance. As I said, technology acceptance has its own adoption curve. Some of this stuff takes years and years and years. So effective, creative policies will have to be used to shorten that adoption curve. R&D going forward should be technology neutral for these competing propulsion systems. We shouldn't attempt at the government level to pick winners. We should let the marketplace do that, let the private sector do that, and invest in these technologies across the range, because you never know where a breakthrough will come. Right now, fuel cell looks pretty good, but if all of a sudden we go from lithium ion to who knows what, kryptonite, that might be the next big thing. And then all of a sudden, we're off and running on BEVs. In all of these scenarios, there's much more work and attention that needs to be focused on the fuels industry. There's a lot, particularly from the greenhouse gas perspective, there's a lot that can be done with these so-called drop-in fuels. So with that, I thank you. I hope I took enough time where I don't get any questions, but
I think you succeeded at that. Thank you very much.